Okay, welcome back. Last time we left off, we were, I think, graphing, adding complex numbers through graphs, through graphing, which is cool because it made a parallelogram, which is kind of neat. We did a lot of other things as well, but I think that's where we left off. Now in this video, we're going to continue with the operations with complex numbers lesson, but this one we're going to be covering the rest of it, hopefully. We're going to talk about I, and I to a certain power, what that's going to equate to, because it does come to be somewhat of a pattern. We're going to be multiplying complex numbers together, which is very similar to multiplying you've done in the past, but we do have to make sure we keep up with the I. And we'll also need to be simplifying or dividing complex numbers as well. So, without further ado, let's kind of get into it. So you can multiply complex numbers by using the distributive property and treating the imaginary parts as like terms. Okay, simplify by using the fact I squared equals -1. So I guess we're going to be multiplying first. I maybe missed that up in my order earlier, but let's multiply these. So it's kind of like multiplying anything else. You're sort of going to distribute. In this case, we have -2y. We're multiplying -2y to 2 and to -4. So let's make sure we're careful, especially when it comes to the I part of this. So -2i times -2 is going to be -4i. And you probably didn't have to write down this step because it's sort of something you just, it was already written here anyway. But yeah, -2i times 2 is -4i. -2i times, I should just stop writing if it's not going to work out. -2i times -4i. So -2i times -4i. So the -2 and the -4 will make a +8, and I make I squared. Now here's the most common thing people will do, is they'll leave their answer like this. They'll, they multiplied it, they'll go, you know what? These are not like terms, and I would agree with you there. They're not like terms. But this is not completely simplified because we still have I squared, is the issue here. When I have an I squared, that's something I can simplify. If you remember from the last slide, it said that. We have to remember, simplify by using the fact that I squared is equal to -1. So remember we said I back in the day equals the square root of -1? Well, if I square I, if I take I squared, then I'm squaring the square root, essentially, which cancels out with it, leaving it as a regular -1. So I squared is equal to -1. So I see I squared here, so really this is -4i plus 8 times -1. Okay, I squared is -1. So really we have -4i minus 8. Okay, and that's our answer. I will say we're good here, we're pretty much done. However, sometimes it does want to write it with the real number first and then the imaginary part second. So although both of these here are the same answer, this is probably how, if it was multiple choice, you'd probably see your answer on a test. Okay? Because again, when we write a complex number, we typically write it as a plus bi, where the real part is first and then the imaginary part is second. So just keep that in mind. Okay? But the main thing when you're multiplying these is when you have I squared, remember I squared is equivalent to -1. Don't forget to include that and simplify from there. Alright, here I've got a complex number, two complex numbers multiplied together. They both have a real part and an imaginary part. We're going to be foiling these. Now, I never really think about foiling because I never go, oh, I'm multiplying the first, I'm multiplying the outer, I'm multiplying the inner, I'm multiplying the last. I usually just go, you know what? I'm distributing 3. Right? 3 times 4, which is going to be 12. And 3 times -i, which makes -3i. So I think I'm distributing the 3, and then I come back and go, you know what? I've distributed the 3. Now I need to distribute the 6i. So right, a positive 6i times 4 would become a positive 24i, because 6 times 4 is 24. And 6i times a -i would become a -6i squared. That's key. Remember, I and I make I squared. So I almost forgot to do that for a second there, but then I remembered. Alright, so now it's about combining like terms and simplifying. So The 12 is still a 12. Really can't do much about that. I do have negative 3i and plus 24i. So these are like terms, I can combine them. Negative 3 plus 24 would be positive 21i. Alright? And then the last thing is we have to remember I squared is equal to negative 1. So don't forget that this is really negative 6 times negative 1, which negative 6 times negative 1 is a positive 6. Okay, and then I actually have more like terms I can combine. Right now the 12 and the 6 I can combine, which would make 18. So 18 plus 21i is our final answer there. Okay, so when you multiply, remember you're distributing. Okay, we distributed the 3. If you go back in time in the video, you can see I've distributed the 3 times 4 to get 12, and 3 times negative I to get negative 3i. And then I distributed the 6i. So 6i times 4 is 24i, and 6i and negative I was a negative 6i squared. I combined my like terms, my 2i terms here. I combined them. And then I also simplified my I squared, which turned into negative 1. So a negative 6 times a negative 1 was a positive 6. And I combined those like terms. Alright? So it is a lot to remember, but it is very familiar, hopefully. You know, you should be familiar with FOILing. You should be familiar with those steps at this point. So let's do it again. Again, let's focus on distributing first. So I'm going to distribute my 2. 2 times 2 is going to be a 4. 2 times negative 9i. Well, 2 times negative 9 is negative 18i. And then I'll distribute the 9i. So 9i times 2 is going to be a positive 18i. And then 9i times negative 9i. So 9 and negative 9 being a negative 81. And the i's make I squared. So before I go any further, let me remember that this I squared is the same thing as negative 1. So really, this is going to be negative 81 times negative 1. So that should be a positive 81 here at the end. Okay? I'm going to bring my 4 down for now. I'm going to go ahead and combine these like terms. I have negative 18i plus 18i, which really, that's 0i, right? So, I mean, we don't really have any more i's because they cancel each other out. So really, what I have is 4 plus 81, which is 85. Right? 4 and 81. Combine them because they are like terms, is 85. So, remember to multiply them, distribute here, combine your like terms. Remember that I squared is negative 1. You should be good. Yep, we get 85. Alright, this one here is just one term and one term, so really just, you know, a negative 5 times a 6, which is a negative 30, and then I and I, of course, make I squared. So this is negative 30i squared, or again, negative 30 times negative 1, which is a positive 30. So there's no distributing here, okay? Because that's just a single term and a single term. It's just like negative 5i times 6i. You know, the parentheses make people think you're distributing sometimes, but if it's just a single term and a single term, you're just multiplying the terms together. You know, that one problem is basically similar to just this last part of the multiplying, where you have 9i times negative 9i. You know, it's really no different than that, where you just multiply them together. So, just because they're parentheses doesn't mean it's distributing. Keep that in mind. You distribute when you have 2 terms or 3 terms inside of one parentheses. We only have 1 term inside each of those. Alright, and this last one, again, distributing. So we have 2i times 3, and then 2i times negative 5i. So we'll have 6i, 2 times 3 is 6, and we'll have negative 10i squared. 2 and negative 5 make negative 10. The i's make I squared. So again, this isn't simplified because this is negative 1, remember? So really, that's negative 10 times negative 1, which is a positive 10. So I have 6i plus 10. So that's my answer, but again, just like the very first problem we did, you usually want to write it with the real part first and then the imaginary part second. Okay, so if I reverse these, I have a positive 10 and then plus 6i, so it's a positive 6i. So that's, again, probably how the answer is going to look on a test in most cases. Okay, it could not be, but you can see that's how they wrote their answer. It's probably going to be written that way. I'm going to skip this one for now, because I feel like we've done enough. But if you're interested, you can see how it works, see how everything worked out. All right, now we'll move on to the powers of I. Ooh, so I to the first power. All right, so it's written on this chart here, but I like to write it down as I talk. So I to the first power, or essentially just I, right, is the square root of -1. We established that from the beginning. We also know if I square I squared is equal to -1, right? We just practiced that. Well, what happens if I have I to the third power? Well, if I have I to the third power, think of this as I squared times I, right? That's 2 i's multiplied by the third I, that's I to the third power. Which we know this is equivalent to -1 times the square root of -1, right? Because I squared is -1, and I is the square root of -1. So essentially, really what that is that looks like negative I, basically, because we're going to just leave this as an I. So this is a -1 times I, or a negative I. I to the fourth power, think of this one as basically an I squared times an I squared. So I squared is -1, I squared is -1, so if you multiply -1 times -1, you have a positive 1. So I to the fourth power is a positive 1. You can see all of those here, right? I, square root of 1, we call that I. Square root of -1, sorry. I squared, we already know is -1. I to the third is negative I, and then I to the fourth is 1. Now, if I try to go I to the fifth, okay, think of this I to the fourth times I. Now, I to the fourth is just 1, right? And then 1 times I is still just I. So now we're repeating the process because now we're back where we started, right? I to the first power equaling I. So what happens here, and you can see it on the rest of this chart, I to the sixth is -1, I to the seventh is negative I to the eighth is 1. I to the ninth is I to the 10th is -1, I to the 11th is negative I to the 12th is 1. So it seems to be a pattern here, right? It seems to go I, -1, right? Negative I, and then positive 1. And then the pattern starts over. I, -1, negative I, positive 1. So, we have a pattern. And this pattern is going to keep going on and on and on forever. And it goes by 4s, right? You go 4, and then it repeats the next 4, and then it's going to repeat the next 4. So now we have to figure out, well, if I have something ridiculous like I to the 44th power or something like that, without having to do this all out, it's going to be one of these. It's going to either be 1, it's going to be either negative I or -1 or positive I. It's going to be one of those, and we got to figure out which part of the pattern that falls in, essentially. And here's my little tip for you on that, okay? Nope. Okay, let me erase this. So my helpful hint for you, helpful tip, is to divide the exponent by 4. Because this is a pattern of 4, if I divide it by 4, then I'll basically break, I'll find where the pattern starts each time. So, if I divide my exponent by 4, so let's take that I to the 44th power that I was looking at a second ago. If I divide my exponent by 4, so this would be 44 divided by 4, I would get 11, right? So if my number that I get ends in 0.25, that's going to be I in the sequence. If it ends in 0.5, it tells me it's the second part of the sequence, which is -1. If it ends in 0.75, it's the third part of the sequence, which is negative I. And if it ends in a perfect whole number, it's the fourth part of the sequence, which is a 1. So this one ends with a whole number, so this would be I to the 44th power would be equal to 1. Alright, so that's my advice to you. Whatever the exponent is, divide it by 4, and look at which one of these outcomes it applies to. So let's try a few together. Okay? Maybe that would help. So here I got negative 6 I to the 14th. So before I worry about negative 6, let's simplify my I to the 14th. So I to the 14th, which part of the sequence is this going to fall under? Well, again, let's take the 14, we'll divide it by 4, we can figure out which part of the sequence this is in. So this is going to be, if you divide 14 divided by 4, I believe it's, what is it, 3.5? Right? So if you look at the little information I've got, if your number ends in 0.5, then that's going to be a negative 1. So I to the 14th is going to be a negative 1. So this is negative 6 times negative 1, so my answer here should be a positive 6. Yep. Okay. Now these slides do it differently than I've mentioned it, so be aware of that. I do not necessarily like their approach to it. I sort of like memorizing the little table that I filled out for you. I like memorizing this because this is pretty much straightforward. It's sort of like a chart I can just go to, look at it, and know what the answer is. So that's why I like it. But if you see the slides doing it differently, just ignore it. Here I have I to the 63rd power. So let's take our process. Let's do the 63. Let's divide it by 4. And I believe this comes out to be 15.75. So I have a number that ends in 0.75. So what did our chart say? Oops. If it ends in 0.75, this is going to be a negative I. Alright, so there you go. I to the 63rd power, that's going to be equal to negative I. Alright, there's nothing else to it because it just wanted to be simplified I to the 63rd power. It didn't have like a number like negative 6 times 4. Alright, so again, their process is a little weird, but they still come up to the same answer. I like my way a little better than theirs. Alright, now we have 1/2 I to the 7th. So 1/2 I to the 7th. So let's take the 7, let's divide it by 4. Here I would get 1.75. And because it ends in 0.75, this I to the 7th is going to be equivalent to negative I, based on the table that we saw like a couple slides ago. So that's going to really come and look like negative 1/2 I. Because this is going to see as a negative 1I, and the negative and the 1/2 can go together. So negative 1/2 I. Right? There's their answer. And then I to the 42nd power. So I to the 42nd power. So let's take the 42, let's divide it by 4, and I believe it's going to be 10.5. So if it ends in 0.5, what was that again? I kind of forget. It's going to make me go all the way back. If it ends in 0.5, it's negative 1. The I term is going to be negative 1. So that's going to be, this is negative 1. Okay, nothing else to it. There's just I to the 42nd power, which equals negative 1. Yep. Alright. I think I'm going to pause this video and stop it there. I don't know if we're covering this on the same day or not, but I don't want this video to get too long. So I'll stop it here, and then what we'll do next is we'll simplify fractions, essentially. Dividing the complex numbers together, okay? Where we get I in the denominator, but we get rid of the I in the denominator. Okay, I will see you in the next video. Adios.